Alright, let's go over the Chapter 6 review number 1. This is covering sections 6.1 and 6.2. And you can see the answers are already filled in there, but we'll go back over and figure out how we got to those answers. So for problem number 1, this is given information over here for size 8, 45, 75. So in this case, it is a side angle side problem. Set up law of cosines because we don't have an angle across from a side, but we can go law of sines very easily. To find 60, we would go 180 minus 75 minus the 45. That turns into 60 degrees. So now we're set up to say 8 over the sine of 60 is equal to, we can start with side A or side C, but typically we're going to start with side C because it's the biggest side, so it should match up because it matches up with the biggest angle. So setting it up like that, plugging it into our calculator and getting C by itself, we do get C equal to 8.92. And so then we can go back in with the similar thinking and find side A. We'll say A over sine of 45 degrees is equal to, and we're going to want to use this one, the given information, just because C, we may have gotten some rounding going on there. So we want to use the exact value of 8 over sine 60. We know that that's correct. Cross multiply, and we'll end up with a value of 6.53 for A. And again, didn't have to check for two triangles, because when it was given, this was an angle, side, angle. One side in between two angles. The only kind of triangle we have to search for or the only type of triangle we search for two triangles is the next one, where we have side, side, angle. Alright, so when we set this up originally, and we say ABC, we do have 33 for A, 17 for B, and 15 degrees for angle B. So we're set up ready to go with our side law of sines. So we'll say sine of 15 over 17, 17 is across from the 15, equals sine of A over 33. And let's do the cross multiplying here so we can see what the numbers are before we get the actual angle. So I'm going to say sine of 15, of course I'm in degrees here, divided by 17 times 33, and I get 0.50. I'm going to keep the rest of the values on my calculator. I'll round just here, writing down there's a 2 as the next one, equals sine A. And so of course to get that by itself, we'll go inverse sine to both sides. That cancels that out, and if we do that, we get 30.16 degrees for A. Now, again, we have a side-side angle. As soon as we do the inverse sine, we have a potential second angle in a second triangle. So as soon as we got 30.16, we need to find the corresponding angle that could show up in our second triangle. We have our answer for A1. We need A2. And the way we're going to do that is go 180 minus the angle we just got, minus the 30.16. If we do that right, we get 149.84. Just simple subtraction from 180. Okay? So potentially we have a second triangle. If all the angles work, we will have a second triangle. And here's how we check if they work. We're going to go 180 minus the angles that we've got, two angles that we have originally, to find a third side. So minus 30.16 minus another 15, we end up with 134.84. That's a valid angle. So we do have a triangle here. For our second triangle, it's 180 minus 15 minus 149.84, and we end up with 15.16, another valid angle. That's in here. So at this point, we have two triangles. All right, so we found our three sides in those two triangles. Now we need to go back in eraser's running very slowly, lagging. We'll get in there. But we do need to go back in there and find our sides, which we're going to do with law of sines. So we'll start with the first triangle. We're going to have to go through this 4 times to find 4 new sides. And so we can start with sine of 15. I would put the 17 on the top just because our variable here, a, is on the top, and that makes the cross multiplying easier, over sine of 30.16. 17 over sine of 15 equals c over 134.84. Cross multiply, we'll get 33 and 46. Oh, I'm sorry. 33 was given. We did not need to do this part. That's an extra step. I already knew about side A. So to find side C, though, we can go right here, and we do end up with 46.57. And we can do the same exact thing on our second triangle here. Sine of 15.16. Again, we'll put the angles in the denominator to make the cross multiplying easier. And on the bottom here, we'll have 17 over sine of 15. Note how these two equations are exactly the same except for the angle that goes underneath C. Sorry, I forgot my sign here. Sine of 134, sine of 15.16. All right, let's move down to problem 3, getting into the word problems. And I'm going to draw as I read so you can see the thought process I would go through as I'm setting this up. A surveyor standing 66 meters from the base of a building. Here's my surveyor. Here's 66 feet. There's my building. Measures the angle to the top of the building and finds it to be 38 degrees. We're looking at the top of the building. He's standing on the ground and looking up. So that angle in there, we find that to be 38 degrees. The surveyor then measures the angle to the top of the radio tower on top of the building. So going straight up, here's our tower. Point T up there. From our surveyor to the top of the tower. That's going to be 50, not another 50, a total of 50 degrees, which makes this angle in here 12 with subtraction, 50 minus the 38. All right, let's find out how tall this radio tower is in here, and not the whole building in the tower, just from the top of the building to the top of the tower. So if we could do law of sines, we'd be in business, but we need a couple more angles. Let's see if we can get anything. I'm going to look at the smaller triangle, this one here, and find all my angles. I have 90 degrees, 38, so subtracting, I'm going to get 52, which means, because this is a straight line here, that adds up to 180 degrees, that this angle inside here is going to be 128. And then we know I have 180 degrees total in a triangle. We already have 128 and the 12. So we're going to get 40 degrees in there. We've got all our angles. So right now the law of sines is going to be sine of 12 matched up with x, and sine of, well, we don't have any other sides. However, if we could figure out this hypotenuse here, because we do have a right angle down here, we would match up the h with the 40 degrees. All right, so how would we possibly get that angle? Well, we have a right triangle and we know an angle, this 38 degrees. Okay, so in this case, I know the adjacent side is 66. I want to know the hypotenuse. Which formula uses adjacent and hypotenuse? The answer is cosine. The cosine of 38 is the adjacent side over the hypotenuse. So we're going to move that around and solve, so it'll end up being 66 divided by the cosine of 38. And I get h is 83.76. So we'll come back over here and plug it in for h, 83.76. And let's cross multiply here. Divide that by sine of 40. Times it by the sine of 12. And we end up with x equal to 27.09. Let's go talk about a rocket tracking station with 2 telescopes on the next page. Alright, so we have a rocking tracking station that has two telescopes, A and B. We'll put them in here. A and B. And these two telescopes are 2.6 miles apart. The telescopes lock onto a rocket and transmit, so a rocket that's going to be up in the sky somewhere, and transmit their angles of elevation to a computer after launch. What is the distance to the rocket from B at the moment? Both tracking stations are directly east. So both stations, A and B, need to be to the east of your rocket. Alright, coming down. We have angles of elevation up to the rocket. That's always from the ground looking up. So we have an elevation here, and we have elevation here. So the elevation from A was 29, and from B was 43. I'm going to pause right away right there. I've drawn this incorrectly, and I know that because this angle, A, needs to be bigger than B based on the drawing. B is further away from R. It's going to be a more acute angle. So clearly we've drawn this backwards. So I'm going to erase here. It never told me that where A and B were. So we can flip their positions here. Make this 43. Make this B. Make this A. Make this 29 degrees. And now it does say we want to find this side here, the distance from the rocket to B. So we're set up here to do some law of sines. We're going to have x over sine of 29 equals 2.6 over the sine of whatever this angle is up here. Don't know it yet, but we could. 180 degrees total minus the 43 is 137. 180 minus 137 is 43, same as this angle here. Minus the 29 is going to be, what do we got? 43 minus 29, 23 minus 9, 14 degrees. So sine of 14 degrees, cross multiply there, divide, we end up with 521 is our distance for x. Alright, let's solve this triangle. We need to do law of cosines here. We're given a side, and the angle in between them. So we'll start with B. B squared equals 6 squared plus 3 squared minus 2. 6, 3, cosine of 25 degrees. And if we plug that in, 6 squared plus 3 squared, which is 9, minus 2 times 6 times 3 times the cosine of 25, I get 12.37. Be careful you don't leave that as your answer. You need to square root it. Common mistake. Square root it properly, you get 3.52. At that point, we're set up to do law of sines for either of these remaining angles. Let's go after the biggest one here. Sine of C, this was side C over here. It's this gamma sine. Either one's fine. Y, gamma, is equal to, we know that 25 is across from our new angle here, 3.52. And sine gamma is across from 6, so we can cross multiply there. And let's see what we got here. Sine of 25 divided by 3.52 times 6 is 0.72. Inverse sine. And we get 46 degrees, which is not our final answer. So how do we end up with 46 degrees here? Remember, anytime we do inverse sine, we have a potential 180 minus situation. Which one are we going to pick? Well, we know that 6 is the biggest side. So gamma here, this side, has to be our biggest angle. If 46 is the angle, 25 is the other angle, 180 minus 25 minus 46, that's 109 degrees. This angle over here, alpha, cannot be 109 degrees. It cannot be the biggest option. So we need to go 180 minus the 46, and we get 133.8. At that point, we can subtract the two angles from 180, and we get 21.2. All right, scrolling down, we're going to do the exact same thing for problem 6 on this triangle. We are given the sides 12, 14, and 14. So we'll start with angle A up here, and that's law of cosines. So we'll go 14 squared equals 14 squared plus 12 squared minus 2. 14, 12, cosine A. Careful with what we're doing here. 14 squared is 196. You add 12 squared, 144 to it, you get 340. Minus 336 cosine A. You cannot put these two things together on the right side. I gotta subtract the 340. 196 minus 340 is negative 144 equal to negative 336 cosine A. We need to divide both sides by negative 336 to get 0.43. And then we need to inverse cosine both sides. And get 64.62 degrees, 64.6. Since these sides are the same, 14 is the same as 14, if we know that A is 64, we also know that B is 64. Saves us the extra step of having to do the inverse cosine again, law of cosines. And then we'll subtract from 180 to find our third side of 50.8. All right, problem 7. 2 points A and B, opposite sides of a building. A and B. Surveyor selects a third point, C, to place a transit. So we're going to put a C somewhere over here. And point C is 47 from A. It is 60 from B. The angle in between A, C, B is 53 degrees. So we want to find from A to B. This perfectly set up for law of cosines. The distance from AB squared is 47 squared plus 60 squared minus 2, 47, 60, cos 53. Just plug it in, make sure you square root your final step, and you do get 49.1. Alright, center field is where we're going here from home plate to center field. Goes through second base to center field was 402. All of these angles were 90, so if I cut 90 in half, we get 45 degrees. And then our problem is how far from first base to center field out there, and we know this distance here is 90. So we're set up for a law of cosines. X squared is 90 squared plus 402 squared minus 2, 90, 402. Come on. Oh, I apologize, computer's freezing for a second. Here we go. 402 cosine of 45. Plug those in, you do get 344.3 feet. All right, last two are both area problems. Scroll down to them. All right, find the area of the triangle. First one, they give you two sides and the angle in between them. So our area formula is 1/2 side 1 times side 2 times the sine of the angle in between them. Plug that in, you get a 17.39. And for our last one here, we're going to use the Heron's formula. S minus A, S minus B, S minus C. Find our semi-perimeter first. That's 8 plus 6, which is 14, plus 3, which is 19 over 2, so 8.5 times 8.5 minus 8, which is 0.5, times 8.5 minus 6, which is 2.5, times 8.5 minus 3, which is 5.5. Multiply them together, take the square root, you do get 7.64. Alright, let's take a look at this bearing problem, the extra credit problem. And so we've got a plane that takes off from an airport on a bearing south, 29 degrees west. So we took off, we were headed from straight south towards the west, was an angle of 29 degrees. Oh, except for I'm making us go towards the east. Sorry about that. We're going towards the west from south. The little coordinate planes, cardinal direction. South, north, west, east. Just as a reminder, 29 degrees is in here. It continues for 20 minutes, then changes bearing south 52 west. So from this point, south 52 degrees towards the west, and lands at the second airport. If the plane's speed is 420 miles an hour, how far from the first airport is the second airport? So we want to find this long distance here. Alright, so first things first, we do know a side length here, 420 miles per hour. If we flew for 20 minutes, that's a third of an hour, so 420 divided by 3 is 140, so this length here is 140. And then after we changed bearing, we flew for 2 hours and 20 minutes, so 2 hours is 840, plus we just found out that 20 minutes gives us 140, so put those together, we get 980 for this side over here. And if we could figure out this angle in between, we'd be ready to go. If we could find a couple of the other angles, we could do law of sines, because we're just trying to find this distance here, how far from the first airport to the second airport. Well, let's think about some angles here with our bearings. And we're going to start with this angle in here, and I think that's all we're going to need. So if we are flying south at 29 degrees, I'm going to make a 90 degrees in here. That's going to make this angle in here 90 minus 29, which is 61. As we go down, there's 90 degrees, 52 degrees, and so I'm going to blow this up a little bit here. We're kind of coming in like this. We want to find this angle. We just figured out this is 61. There's 90, going straight down. And we know that this angle in here is 52. A full circle all the way around is 360. How much is left? So 360 minus 61 minus 90 minus 52. We got 157 degrees in here. And so we're ready to go law of cosines. X squared equals 980 squared plus 140 squared minus 2 times both of them, 980 and 140, times the cosine of 157 degrees. Plug them in, take the square root, you get 1110 as your answer. Tough one. If you can figure out the bearings, you're going to be in good shape for any other extra credit problems you might see. Alright, that's the 6-1, 6-2 review.